Hey everyone, welcome back to the channel. In this video, I'm going to go over hexadecimal math and how to convert between decimal and hexadecimal. Before we get into hexadecimal, let's look at something that we already know, which is decimal. With decimal, numbers divide up by placeholders, and those placeholders range anywhere from 0 to 9. And decimal is a base 10 system, meaning that every subsequent placeholder is a multiple of 10. So in this case, we can see the first position is the ones position. We multiply that by 10, we get the tens position. We multiply the tens position by 10 and we get the hundreds position, so on and so forth. So if you have a 4-digit number, then you have a placeholder for 4 digits, and the value of those digits depends on where they fall in terms of the value of the placeholder. So if you have a number such as 6492, you would take that value, multiply by the placeholder, and in this case, you would get 6,492. So hexadecimal works in a similar way. However, this is a base 16 counting system, meaning that the placeholders can have a value ranging from 0 to 9 or A through F. And in this scenario, A would be equal to 10, B is equal to 11, so on and so forth until you get to F, which is equal to 15. And in terms of the formatting of a hexadecimal number, you will typically see it preceded with a 0x. So it would look something like this, for example. So let's take a look at a couple of examples where we convert from hexadecimal to decimal. So as we went over, hexadecimal is a base 16 system where you can have the values of 0 through 9 or A through F. So if you have a hexadecimal value of 0xc, for example, the first thing we need to do is identify the value of c. And we went over before how A is equal to 10, B is equal to 11, and C is equal to 12. So we would take that value of C, multiply that by the placeholder that it sits in, which is the ones position. So this is 12 times 1, and we would get the value of 12. So we have the decimal value of 12, which is the equivalent of 0xc in hexadecimal. So let's take a look at another example. What if we had something like 0x1a? So we already went over that a is equal to 10. And where is this sitting? This is sitting in the ones position. As we went over, we take that value, multiply it by the placeholder. In this case, it would be 10 times 1, which is equal to 10. Now, if we look at this other number here, 1, this is in the 16s position. So when we multiply this out, this is going to give us a value of 16, which is 1 times 16. If we take those values and we add them up, we get the value of 26. So 26 is the decimal equivalent of the hexadecimal value of 0x1a. So let's take a look at a couple of examples where we convert from decimal to hexadecimal. So if we have a decimal value of 20, for example, what does that look like in hexadecimal? And this is similar to the concept that we went over in a previous video of converting from decimal to binary, where we have placeholders and we want to find the highest placeholder that can fit inside of the decimal value. So if we take a look, we have a ones position and we have a 16s position. So for the ones position, we went over for hexadecimal, we can have 0 through 9 and A through F. So effectively, we can have any value in the ones position from 0 to 15. Now, if we look at the 16s position, we can also perform the same function as well. However, we have to keep in mind that this is going to be a multiple of 16. So if we put a 2 here, for example, it's going to be 2 times 16, which is 32. And 32 is larger than 20, so it won't fit and that won't work. However, if we put a 1 here, that would be 16 itself because it's 1 times 16. And then if we put a 4 in the ones position, that would be 4 times 1, which is 4. And then 16 plus 4 is 20. So the hexadecimal equivalent of 0x14 is the decimal value of 20. So let's take a look at another example of this. What if we had a decimal value of 100? What would that look like in hexadecimal? Well, we know that the largest amount that you can get in the ones position will be 15, so that's not enough. We need to go to the next level. So if we look at the 16's position, what can we put inside of there that gets us close to, if not equivalent to 100? Well, if we put a 6 in the 16's position, 6 times 16 is 96. And then we have the leftover 4, which we could just put a 4 in the ones position. 96 plus 4 is 100. So the hexadecimal equivalent of 0x64 is the decimal value of 100. If you have any questions about what was covered, please leave a comment below. If you enjoy these tutorials and want to support my work, please like this video and share it with others. If you have the means, you can contribute to my Patreon or leave a tip in my jar. Be sure to subscribe to stay updated to my latest content, and thank you all for watching.